Okay, so our data is grouped into two. We have discrete data and then we have continuous data. So discrete data refers to the information that can only take exact or fixed values, like the head count or number of phones, counting the number of phones that you have, counting the stationery that you have, as fixed values. They can be in decimals as well, but they have to be fixed. They have to be independent, each occurrence. And then more points to note, discrete data can only accommodate what we see, fixed or exact values. And then raw data is the data that was sampled or recorded without any order. We looked at that before in the key terms. And then discrete data can be made up of decimal numbers as well apart from the whole numbers, as aforementioned. Okay, so let's look at this example of discrete data. One winter day, the security guard at a new shopping complex, it's a small shopping complex, you might be surprised with the values that you're going to see, but it's a small shopping complex. Let's put that in our minds, hypothetical. Wondered if people were ever going to show up at the shopping complex. So he decided to count the number of cars which arrived at the complex after every half an hour during his 7 working hours. So basically, after every half an hour, he would start counting again. The results were as follows. So those are the results we're now saying how many times did he collect the data. It was 14 times, because we're saying how many half hours are in an hour. It means there are 2 half hours in an hour. So if we say 2 by 7, we get 14. So we're saying there are 14 half hours. So there are 14 times in which he was collecting his data, or he was counting the cars that arrived. So the first question would be, state the type of data using the information provided. So the information provided is what's in that box, in that rectangle. And then the second question is, organize and tabulate the sampled data showing the frequency distribution. We're going to look at that. Then represent the data from the table in a vertical line graph, or rather end a histogram. We'll look at both ways of representing the data. So let's get on with it. So the answer to the first question is discrete raw data. It's raw because as you can see in the rectangle, the number of occurrences or the number of cars are just random in there. And then it's discrete because he was counting fixed value. So he could count, this is one car, this is the second car, this is the third car. There was no like a range of conjoined cars or whatever. No, there's independent cars coming at different times or in the same time. And then we have the number of cars there in the first row, and then the frequency in the second row, as you can see with the requirement of the part B of the question. So as you can see with the first, we're trying to say, for if we had one car coming in 30 minutes, then it means that the frequency has to show us how many half hours did we have one car coming. Like we said, this security guard was actually concerned that maybe people might not come because it's very cold, it's a winter day. So we see with one car, there was no half an hour that had one car coming. But with the 2 cars, we won't have 1 30-minute period. And then with 3 cars, 1 30-minute period. You can see that in that rectangle. So at the end of the day, if you add up all the frequencies, they should give you 14, because the frequency represents the number of 30-minute periods that are in that in the 7-hour working time for that security guard. So the security guard works for 7 hours, but after every 30 minutes, he was counting the number of cars that arrived. So I want to see how many 30-minute period did we get 2 cars? How many 30-minute period did we get 4 cars? How many 30-minute period did we get 10 cars? How many 30-minute period did we get a single car? Or how many 30-minute period did we not even get 1 car? That's basically what the frequency is trying to entail or show. So we then see that being portrayed there, and 6 cars came in almost 4 30-minute periods. So that's the mode. So if we are to present it in a line graph, that's how it will look like. So we have to put the scales you have to decide the scale by yourself. So you decide, okay, what fits on that line. It'll be from 0 to 10 in the horizontal and 0 to 4 on the vertical for the frequency and the number of cars. Make sure you label with the titles that you gave for each row in the table. That's the one you use for the graph, so that it makes sense. And then we move on to the histogram, which is basically the same idea. So you're going to see that the only difference is with histograms we have sort of rectangles. Those rectangles, maybe we call them bars, but let's just call them rectangles, and you put them in different colors so that you can distinguish that they are for different values. And as you can see, the values for the number of cars, they are directly in the middle of those rectangles, so it shows you that that's where the peak number is, the average number there. And then you are going to see that they are joined together. That's why we call it the histogram. For bar graphs, it's a bit different. They have equal spacing between each and between the rectangles, so you have to take note of the difference between a histogram and a bar graph. We're going to see the bar graph later on, but this is what we call the histogram. So this is how you represent the information. You take the values from the table, and then you put your scales, you show the ranges of your scale and all that, and then you plot the graphs according to what's in your table, and then you'll be good to see which one has the highest and which one has the lowest values as it is graphically represented. And it's better to also put it that way for the layman to understand. You get what I'm saying when you look at the graphs, unless if you're very interested in values and digits and all that, yeah, then the table is good for you, but the graph makes it easier for almost everyone to understand.